Hey guys, just having a look at 2002 Junior Cert Higher Level Question 5 on Transformation Geometry. It's a bit of a different setup to what we're used to seeing in the recent papers. We're not given a lot on the page as such, we're just given the initial figure, and for once there's no real tough geometry here, there's no real constructions involved. It's just a very basic, all measurements given and draw the figure exactly as it is. There's no tangent lines, points of contact, nothing. So that was a nice pleasant start to the drawing. We're given a line RQ. The height of Q lines up with the top of the figure, and it's at a 72-degree angle, so either use your protractor or adjustable set square to draw that. We're given a point S, then 75 mil down from the center point of the object right here. Now, to have a quick read of the question, the figure of the rosette shown is subjected to transformations in the following order. Axial symmetry in the line QR. So QR being the axis, so we're going to take the object, flip it through and onto the other side. Part 2, translation equal to QR. So taking our new object in its new position and sliding it down parallel to QR, the same distance as QR. And finally then, central symmetry in the point S. So wherever it lands down here, we go through point S and out the other side. Draw the given figure and determine the image figures in each of the transformations. So again, in contrast to the newer questions, no rotation. So actually quite an easy question, but let's give it a go. The first thing is QR is a little bit short in its own position as it is right now, and I want to save myself the hassle of having to come back after, so I'll just extend on QR a little bit. An axis can be any length. Now the important thing is, when we come back to this later, that is point Q and that is still point R. I've just extended it so that I can help myself when I'm doing my axial symmetry. If you have an adjustable, it makes this job quite fast. If you don't, well, we use our sliding set squares. Set up the 72 angle, the angle of QR. And I'm just going to do it this way, okay? I'm going to use my 90 degrees. I'm not going to be doing a lot of moving here if I can. I'll slide down until I'm just past the back of the object. And I'll go and slide in a different manner, like this. Now, top of the circle I could take, but we'll see. Might not necessarily need it. We'll take the center. I'm going to take that point. I'll take that point, and maybe just this one right here. That's all I need. Now, if I need to come back and catch some other point after, I'll do that. But for now, I think that's all I need. As always, I'm going to add on my little label. This is nice just to clarify it in our own heads that we've gone perpendicular. You can add it to all of them if you want, or else just add it to just the one. But every projection is perpendicular to the axis. Next, it's time to mirror those points. So accurately, we place our compass on the axis. We open it up to the center of the circle and mirror it across. We could do one at a time and start drawing the object, but I think it's just far more efficient to do them all. Now, what I probably should have started off by doing was actually doing some numbering. So I'm going to start off with point 1 up top, point 2 down the bottom, 3, 4, 5 and 6. I didn't take point 1, but I might find it later. 6 is the center of the circle. 5 is a point on the circle and it's a point on the line. So 5 is here. 4 is here. This is 3 here and 2 in here nearby. And is that all my points? Not one yet. Now, the great thing here is I've taken the center point of a circle and a point on the circle, so I don't need to measure anything here really. I can just go ahead from the center point number 6 out to hit point number 5 right there, and I can draw myself. I can follow on now, and I know that 4 to 5 is solid line. 3 to 6, and going right through will take me up to get point 1, because 3 through 6 got me 1 the last time, even though I don't necessarily need 1. 4 joins up to 3, 3 joins down to 2, and 2 goes up to 1. Oh, there we go. There was a reason we needed 1. So 2 joins up and hits point 1. So there's our first one, axial symmetry done. Moving on. Translation equal to QR. Now I'm just going to add, I still have my adjustable set here to 72 degrees, and I'm just going to grab a red colour and just highlight the line QR, because I think if there's going to be a mistake on this part of it, it's going to be the length of the line. I'm going to put the adjustable away because maybe everyone's not working from one of those. I'm going to set up the angle QR using my sliding set squares. So I want a translation equal to the red line, and it's like always, a translation works with 2 keywords. Translation is equal to distance plus direction. The distance the object is going to travel and the direction it's going to travel, and both of those are defined by this one line. The red line gives us a distance and a direction. So first of all, we'll set up the direction of the line, which was 72 degrees. Again, if you have an adjustable, it probably makes this a little bit faster. If not, then just do what I'm doing. Let's set our direction first. We'll just take them on down. Every point that we used last time, we'll take them down again this time. Now, that's one part done. That's the direction. Next is the distance, and the distance is equal to the line from Q to R. That's how far the object is going to move. Now, I'm not going to work with point 1. I don't want to give myself a center and 2 points in the curve. I want to give myself a center and 1 point. So 0.5 is here, 0.6, which is the center, is here, 0.4, 0.3, and 0.2. That's all I need. I'm going to number my points, so I haven't even taken 0.1 yet. 0.5 here, 0.6 here on center, 4 is down here at the bottom, 3 is up here, and 2 is just there. I'm going to draw my circle again from the center 6 out to number 5. From the center 6 out to number 5. And now, this is kind of hard to get it accurate. I'm going to go back to my original and make sure I am accurate with this, setting the exact same size. I am. Just in case I've built up an error as I'm working on. There's my object. Same as before. 5 to 4 to 3 to 2, and I need 0.1. Do I have it? Well, I do. Well, and I just verified this. So I have 0.1 because I projected it and it hits the circle there. And just to verify, 3 through 6 should get me 0.1. So 6 and 3 joined and extended should get me 0.1. So that's okay. That has worked out quite well there. Now, 4 to 5 down to 4, 4, up to 3, 2, and finally up to point 1. There's my translation. So I've taken it the distance and direction specified by the red line. That's part of the drawing. Central symmetry in point S. So S is the center of symmetry. Look, there's not going to be anything too major about this one now. If we get this far, last part is quite simple. We'll take all the points again, and I'm going to run a very similar system to every other one. We'll take all of our points through point S and out the other side with my 5H pencil. If you find this step confusing, one point at a time. If you're comfortable with it, take all points at the same time. But just beware. This is the part, so where I'm going to start now. I might just get the rubber for a second and just rub out this line here, because that's the vertical line that I used from the starting point of my drawing up here to just find point S. Now that I've that rubbed out, I have 1, 2, 3, 4, 5, 6 lines coming in, and I have 1, 2, 3, 4, 5, 6 lines coming out. So it kind of makes it a little bit easier. It simplifies the process, and it removes any chance of error from our drawing. So starting off down there at point 2, working up to point 2. We can number as we go along if we want this time. That's 2. Starting off on this one down to 4, and I think it's a good idea not to skip them. Start with the bottom line, move on to your next one, and that way you're working around in a structured manner, in an organized manner. So that's down to 4, and that's up to 4. Next one is from point S down to 3. And then we've used 2, we've used 4, that's 3. Next one is up to 5. And there's 5. Then we get 6. And much like the previous 2 times, I'm not going to take point 1 for now. I don't want there to be a chance of being off by a millimeter here. I'm going to draw the circle now. I've verified that my circle is the right size, linking it back to the first one, and then I'll make sure the point 1 matches up perfectly. So the radius of the circle, once again, is the distance from 6 to 5. Just check that back to my original, and that is good. So from 6 to 5, I can draw my circle. I'm not even necessarily sure yet what way this is facing. All I know is that the radius of the circle is defined from 6 to 5. If I just verify now, just to check, point 1 here should be landing on the circle here. So point 1. 3, 6 and 1 should all be in line. If I just add in that central axis now again and keep it light, that's 3, 6 and 1. And then it's time to join the dots again. So 5 to 4, 4 to 3, 3 to 2, and 2 towards 1. And there I get my object. That's the complete drawing. So the figure of the rosette is shown subject to transformations, axial symmetry in the line QR, so flipping it over with my 90 degrees marked. Translation equal to QR, that being, and I forgot to tick off my distance I used by setting the compass, and the direction by sliding set squares. And finally, there was a central symmetry in the point S. Now, that's that drawing complete. Hope this video helps.